Hello, good morning. I am discussing about some questions related to UV structural elucidation questions. First of all, first question: the flowing dynes have lambda max at 176 nanometer, 211 nanometer, and 250 nanometer. Find out which in which. Okay, structure one, structure second B, and structure C, all are dimes. In case of first, lambda max equal to 176 nanometer indicates that there is no conjugation in the molecule. Compound C has no conjugation, hence the compound showing lambda max at 176 nanometer is the structure C, that is 1,4-pentadiene. In the structure C, uh, this is the diene but no conjugation. So in the alkene, the observation is around lambda max 176. So structure C, 1,4-pentadiene is the lambda max 176 C, 176 is the structure C. This is the 176 nanometer because in this structure there is the no conjugation of the diene. Structure A and B are the geometrical isomers of the compound 1,3-pentadiene. See, structure A and B. Structure A and B are the isomers. Structure A is the cis position, same side, that is the cis position. This position, this, that is same side, same side of the similar groups. But in case of structure B, it is the opposite sides. So it is the trans. That is opposite side. So structure A and B are the geometric isomers of the compound 1,3-pentadiene. A is the cis isomer and B is the trans isomer. As a result, the trans isomers show absorption at higher wavelength. Hence, the compound showing lambda max 215 is the B or trans, and compound showing lambda max 211 or cis 1-pentadiene. 215, 215, This is the trans and 211 is the cis. This is the 176 because that is the no conjugation of the diene. Another question, question 2. Which of the following compounds, if any, can give a UV spectrum showing lambda max at 218, Emax 18,000, lambda max 245.5, E equal to 9800, 9800, lambda max 186.5, E 450, lambda max 414, E 63,000. Structure A, B, C, D. In case of structure A, this is the butane does not have any conjugation. It does not have even one double or triple bond. Therefore, lambda max values correspond to this compound. In case of structure B, this the propane has the triple bond, but the electrons are not much mobile. This compound observes lambda max 186.5 nanometer. In case of alkene, the absorption range is 186 around. Structure C, 2-butanol, in case of 2-butanol, has the conjugation with possibility of resonance. This compound lambda max 218 nanometer. We know the in case of diene, the open chain structure have the lambda max value 217. Methyl phenyl ketone has the 3 double bonds of the ring and double bond. This is the methyl phenyl ketone. Double bond in the carbonyl group are in conjugation. See this double bond and this carbonyl group, that is the possibility of the conjugation. So the number of double bonds in the conjugation is much more than in compound C. Thus, compound D observes 245 nanometer. In case of C, in case of 2-butanol, in comparison to 2-butanol and methyl phenyl ketone, the value of absorption is higher in case of methyl phenyl ketone. So the absorption of the compound D is 245.5 nanometer. Question number 3, indicate the increasing order of wavelength of lambda max of the following compounds in the UV region of the spectrum. Compound C has no double bond conjugation molecule. C, compound C, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 4, pentene, pentadiene, in case of 1, 4, pentadiene, and there is no conjugation. So it will have the smallest value of lambda max Compound B having two double bonds in conjugation will have intermediate value of lambda max. See, compound B, in case of compound B, 1, 2, 3, 4, 1, 3 butadiene, in case of 1, 3 butadiene, that is the possibility of conjugation. So, having the two double bonds in the conjugation will have intermediate of lambda max between A and C. Hence, increasing order of wavelength of lambda max for the compound ABC in this order. Question number 4. The UV spectrum of acetone shows two important peaks at lambda max, 279 nanometer, Emax equal to 15, and lambda max 198 nanometer, Emax equal to 900. Identify the electronic transition for each. Lambda max 198 nanometer, Emax equal to 900 correspond to n pi star, and lambda max 279 nanometer, Emax 15 correspond to pi star. N pi star, lambda max 198, and pi star 279. 198, 279. C. Question of 5. What type of compounds absorb UV radiation? Select the compounds in support of your answers from the following list. 1,3-butadiene, 1-hexane, cyclobutane, 1,3-hexadiene, chlorobenzene, nitrobenzene, chlorocyclohexene. This is structure. Okay. What types of compounds absorb UV radiation? Select the compound in support of your answer from the following list. These are the compounds I've given. This is the structure and the name of this compound. The cyclohexene, chlorobenzene, nitrobenzene. So we have to clear in the answer to answer of this question, know about UV radiation. What type of compounds absorb UV radiation? We should know in this, the list of these compounds have UV radiation, UV absorption or not. We have to be sure about that. So, in case of 1,3-butadiene, this is the 1,3-butadiene. There is the double bond and with the conjugation. So definitely and these compounds have the UV rays. Compounds having conjugated double bonds absorb UV radiation. We should clear about this. The compounds having the conjugated double bonds absorb UV radiation. So, structure first, 1,3-butadiene absorbs UV radiation. one hexane, in case of one hexane, in case of one hexane, see, one hexane, in case of one hexane, there is the no double bond. So there is the no possibility of absorption of UV radiation. Cyclobutane, also cyclobutane. Cyclobutane also same case. There is no possibility of double bond conjugation. This is the cyclobutane. No double bond. So there is no possibility of UV radiation absorption. One 3-hexadiene cyclobutane. In case of 1,3-hexadiene, 1,3-hexadiene, 1, 2, 3, 4, 5, 6. Okay, it's the 1,3-hexadiene. There is the double bond with conjugation. So definitely these have the UV absorption. In case of chlorobenzene, okay, this is the chlorobenzene. Chlorobenzene have also possibility of conjugation of this double bond. So this have also possibility of UV absorption. In case of nitrobenzene, see nitrobenzene, structure of nitrobenzene, this have the possibility of double bond. So this also have the possibility of the UV range absorption. Okay, I have already discussed about this. I have written answer. Compounds having the conjugated double bonds absorbs UV radiation. Out of the list given, the following compounds will absorb UV radiation: 1,3-butadiene, 1,3-cyclohexadiene, chlorobenzene, and nitrobenzene. Question number 6. Arrange the following in the increasing order of UV absorption maxima: anthracene, ethylene, naphthalene, butadiene. UV absorption maxima depends upon the number of conjugated double bonds in the compounds. Greater the number of such double bonds, greater will absorption maxima. Out of the list given above, anthracene 7 conjugated double bonds, naphthalene has 5 conjugated double bonds, butadiene has the 2 conjugated double bonds, and ethylene has no conjugated double bonds. Therefore, the increasing order of UV absorption maxima of the compounds will be under the ethylene, butadiene, naphthalene, and anthracene. Question number 7. Can UV spectral data be useful to distinguish between the following pairs of given give region? Ethyl benzene, styrene, and What is this? What is the name of this compound? Okay, 1, 2, 3, 4, 5. 1,4 pentadiene. 1, 2, 3, 4, 5. 2, 4 pentadiene. This is structure of ethyl benzene and styrene. Ethyl benzene has 3 conjugated double bonds. Ethyl benzene, 3 conjugated double bonds. And styrene has 4 conjugated double bonds. Styrene, this is structure of styrene, 1, 2, 3, this is 4 conjugated double bonds. And these two compounds can be differentiated by observing the lambda max value. Styrene will observe higher wavelength compared to ethyl benzene. 1,3 pentadiene has conjugated double bonds with observes UV radiation. 1,4 pentadiene does not have conjugated double bonds, therefore it does not show maximum UV range. 1,4 pentadiene C. 1,4 pentadiene 1, 4, 1, 2, 3, 4. Okay, this compounds 1,4 pentadiene have the no conjugation. But in case of this compound, 1, 2, 2, 3, 4, 2, 4 pentadiene have the conjugation. So definitely the 1, 3 pentadiene conjugate double bonds. It absorbs UV radiation. 1, 4 pentadiene does not conjugate double bonds. Therefore, it does not show absorption maximum in UV range. Okay, question number 8. Which have the greater lambda max? This aniline and trichloroamine. Lone pair of electrons on nitrogen is available for conjugation with double bonds of benzene in structure first. In structure second, there is no electrons on nitrogen for conjugation with the benzene ring, hence structure first shows greater lambda mass compared to structure second. See, in this structure, in case of amine, are it a lone pair of electrons? This is the possibility of the conjugation. But in case of trichloroamine, the plus charge, absence of lone pair. This is the lone pair. But in case of this compound, absence of lone pair. Absence of lone pair. So the structure first shows the greater lambda max compared to structure second. Question number 9. Mesitile oxide, a condensation product of acetone, is known to consist of two isomers, first and second, shown below. One isomer exhibits a maximum at 235 nanometer with Emax 12,000, while the other shows no high intensity absorption above 220 nanometer, which of the two isomers observes at 135 nanometer. See, this is structure first and structure second. Have given in the question. Isomer second observes 235 nanometer because its double bond system is conjugated, while Second has unconjugated. Okay. Isomers structure second have a 235 nanometer because its double bonds system is conjugated, while uh, this is the not structure second, structure first has unconjugated double bonds and would be expected to observe at shorter wavelengths. Question number 10. How will you differentiate between the following compounds using UV spectroscopy? What's the name this compound? Acetone and phenyl acetone, acetophenone. In case of acetophenone, that is a sort of conjugation with the ring as well as outside the rings. Here is also double bond. Okay, this is the conjugation and outside ring, also conjugation. What is the in the propanone gives absorption maximum 166 Emax 16,000 methyl phenyl ketone 1 phenyl nin ethanone will show the absorption maximum at a much higher wavelengths due to conjugated double bonds in the ring. Also, carbonyl group, carbon double bond oxygen is the conjugation with the double bonds of the benzene ring. Which of the following absorbs and which do not absorb UV radiation? Ethyl alcohol, benzene, water, acetone. Benzene and acetone absorbs UV radiation, while ethyl alcohol and water do not absorb UV radiation due to absence of conjugation of double bonds. Question number 12. Compounds ABC have the formula C5 acid and on hydrogenation yields and pentane. Their UV spectra show the following of lambda max. A 176 mu, B 211 mu, C 215 mu, on pentane 170 mu. What are the likely to structure of A, B, E, and C? Formula of C5 acid suggests that the molecules has two double bonds in all the three compounds. If the two double bonds are conjugated, the absorption takes place around 220. Accordingly, compound A is 1,4-pentadiene. Compound B and C both 1,3-pentadiene. Out of the B is cis isomer. B is cis isomer and C is the trans isomer. This is the because trans isomer absorbs trans isomer absorbs at higher wavelength. Absorbs at higher wavelength. So A is this compound, B and C. Okay, it's all about some questions related to UV spectroscopy in structural elucidation. Thanks for watching and request you all like, comment, share, and subscribe. Thank you for patience. That is now. Bye bye. See you again.